In this video, I'm going to demonstrate cost estimation, the high-low method, the scatter graph, and also regression, both simple and multiple regression. And I'm going to use problem 568 as a demonstration. I think it'll be a little bit easier to do this in Excel, so I've just shifted over to my Excel spreadsheet. And ultimately, they're wanting us to predict cost. That's going to be our dependent variable. They have a variety of historical information from different stores for this company, and the prediction is that some combination of employee and or revenue, those are our independent variables, are going to help us predict costs. So we also have that corresponding information for employees and revenue. The starting point is the high and low method, and they ask us to predict costs based upon employee only. With the high and low method, I'm using the highest activity point and the lowest activity point. So in here, that'd be the highest and lowest employee, and then look for the corresponding costs. To make it easier, so I don't accidentally select the wrong item, I'm going to go ahead and just sort this. So it's a lot easier to see those high and low activities pop out, and I'm just going to highlight them. So some important things here is the lowest activity level does correspond to the lowest cost, but that's just a coincidence. That may not always happen. 26 employees and the corresponding cost is 2,374. The highest activity doesn't necessarily correspond to the highest cost, which can occur. But we want to pick that highest data point, and that's 54 employees, and its corresponding cost is 5,029. So if I list this information here, again, my high cost is going to be 5,029. Really, that's 5,029,000. And my low cost is going to be 2,374. Again, high activity is going to be 54 employees, and low activity is going to be 26 employees. So what I'm doing is I'm going to draw a straight line just only through those two data points, ignoring everything else. And the first thing I'm going to go after is what is the slope of that straight line? Because the slope of that straight line is going to predict what the variable cost is. Every time we increase employee, what do we believe the cost is going to increase by? So I'm going to look at the change in cost. 5,029 minus 2,374 is a change of 2,655. I'm also going to look at the change in activity from the high low. 54 minus 26 is 28. So if I take my change in cost, 2,655, divided by my change in activity, I get an estimate of my variable cost per unit of 94.8 if I go ahead and round it. What that's saying is for every employee we add, we're going to add about $95 in cost. Now I'm going to go after my fixed costs. So think about this. Total cost includes two things, variable and fixed. We already estimated variable, or we can estimate variable. So if I take either of these two data points, the total cost, I'm just going to use the low. If I take that 2,374, again, variable plus fixed. If I subtract out the estimate for variable, I'll back into fixed. And again, I can do this for high or low. So 94.8214, multiply that times the corresponding number of employees, which is 26. And so my fixed cost, unusually enough, normally this is a positive number and above zero, but it happens to be negative 91.3571. So over here, you might have noticed this. I had my straight line formula building. Looks kind of crazy because I don't have these numbers rounded. Really, it's y equals, or cost equals, negative 91.35. Let's just go ahead and stop there. Plus 94.82. Let's just stop there, times x, or times the number of employees. So if I'm predicting the cost at 30 employees, I'll come down here. I can just say equals my fixed cost of negative 91.3571. I didn't round that at all. Plus my variable cost per unit of 94.82, on and on and on. Again, I didn't round it, times 30 employees. And so I have this rounded. It's going to be about $2,753. Again, really it's millions. So what's good about this? We're all going to, if we do it right, we're all going to calculate it the same. It's scientific. We're all going to come to the same number as long as we pick the right data point. What's bad about it? I am only using 2 data points. I'm ignoring the wealth of other information that I have that could predict it. And the reality is the 2 data points I pick may be outliers. They may, highest and low activity may be outliers and they may not really help predict. So what can I do next to really see this data and understand whether they fall in line with everything else or whether they are outliers? I can do what's called either a scatter graph or a scatter plot. Now, for your problem, they have you do this in Connect, and I'll admit it's a bit of a slow process. It's much easier to use the power of Excel. So bear with me on those problems that you have to do. I'm going to go ahead and highlight, again, predicting costs based on employees. So I'm going to highlight that information. I'm going to go to insert. I'm going to go to my scatter graph here. And I realize this probably is tough to see on the video, so let me try to expand it as much as possible to see it. What's nice when I do the scatter graph or scatter plot is I can definitely see some data that's in line. But I also see a lot of outliers, and those outliers are going to skew the information. And one thing I'll point out, no, that's going to be very hard to see on a video is, remember the high data point was 54 employees and $5,029. That looks awful lot like an outlier. So we were using that in the high low. What's also neat that isn't talked about in the book, Excel just has so many powerful features, is if, I highlight this data and I go ahead and say add trend line. I just right clicked, or I can go to this plus sign and I can also add the trend line that way. And that's going to go ahead and add a straight line. So we can see that, again, it fits quite a bit with a lot of this data, but then we seem to have these outliers that's shifting it a bit up. And then I'm going to go over here and I'm going to say display equation and display the R squared. By doing that, ultimately the trend line is performing regression. Here it's simple regression because we only have one independent variable, and that's employee. It's ultimately performing regression here. The R squared, if you remember from regression, gives us a sense of how much variability in that dependent variable cost is being explained by employee. At 0.7, it's not great. So again, I would want to look at this data and say, is this the right independent variable, or are there outliers that I need to throw out even before I get into playing around with my simple regression? I'm going to go ahead and move on though and follow along with what this problem asks us and jump into simple regression. So with simple regression, they're asking us again to predict cost only based on employees. So we're still going to ignore revenue. Again, the power of Excel makes this pretty easy. I'm going to highlight the cost in employees. I'm going to go ahead and go to data analysis. Because I've been playing around with this, it automatically went to regression. Unless you're typically using regression, it probably won't go there automatically. And select that. And I'm going to select my Y. It won't always be able to predict it for you. My Y is my cost. That's, again, my dependent variable. My X is just going to be my employees. So far, I'm just doing simple regression. I went ahead and indicated to select that I have selected the labels. That's just saying I already selected the headings of cost to employee. And my output, I'm going to put on the sheet. I'm already designated a spot that I know it'll fit. I just got a message because I'm overwriting something I did before. And just in, a few clicks here, we have this information. To solve the rest of the problem, I'm looking for the information towards the bottom, and I'll go ahead and highlight that. What are the coefficients for the intercept? That's going to be our fixed cost. And then also, what's our coefficient for employees? Again, that's going to be our variable cost per unit. But what's powerful about this is, compared to the high-low, we again use all the data points, so that's much more powerful than just using 2 extreme. But we also have a variety of different measures like our t-squared and particularly our r-squared that is telling us how much of the variability of cost is explained by employee. Now, 0.7 isn't horrible, but that's definitely telling us we can improve upon this. Again, maybe it's just simply removing outliers. Maybe it's multiple regression. Maybe we just don't have the right independent variable at all. But again, I'm going to move forward with just solving what the problem asks us. Up above, I'm going to indicate the regression coefficients for the intercept or fixed cost. It tells me to round it to 1 decimal point. So I go down here and recall that that's going to be negative 162.9. Employee, again, go down here, and that's going to be 103.1. So if I use this, it would be y equals negative 162.9 plus 103.1 times x. So to predict it at 30 employees, again, I use the intercept of negative 162.9 plus my 103.1 times 30 employees. That's what I'm predicting. And my cost is estimated to be 2,930.1. Before it was, I believe, 2,753. So I definitely have a change based upon using all of the data points. But again, it's still not perfect. My R squared is still a bit low. So let me try multiple regression. But same process, it's just I'm using more independent variables. So I'm going to go ahead and highlight revenue because I'm going to try to see if revenue is going to help be an additional predictor here. Go back to data analysis, regression. My Y value stayed. I can see it stayed at cost. But I'm going to have to change my X range because before it was just employee, and I want to go ahead and change that to revenue. Again, I pulled the label, so I'll leave that and I'll leave my output range. I'm going to keep it simple and just go ahead and say OK here. And it's going to pull this information. So again, let me highlight what's relevant to solve the rest of the problem and get my coefficients related here. But before I do that, if you recall from the book, when we use more than one independent variable, it's better to use adjusted R squared than R squared. And we can see here that, we're not really moving in the right direction. It's 0.6538. So again, you might think, well, if I add something else, that's going to be better in predicting. It didn't really help us predict any better than where we at. And if you stop and think about this, does revenue really drive cost, or is it, if cost is mostly variable, they move along in the same direction, but this fixed or it's unrelated, then no, it's not going to be a good predictor. It really doesn't seem like we've helped ourselves. Also, if you recall from the book, it's better to have a t-squared greater than 2. And again, I'm definitely not moving in the right direction there. So if I'm in the real world, I would say, I don't think I'm going to go any farther. But again, I'm going to go ahead and work through the rest of this problem. The fixed or intercept, going down here, rounding to 1 decimal point, is going to be negative 204.2. The employee, again, go down here, is going to be 105.5. And I know I'm going to have to scroll down a little bit so that you can see revenue. You notice, again, it's negative. But if you think about this, cost, unless we're unprofitable, is going to be less than revenue. So it makes sense logically that it has to be negative. Round it to 2 decimal places. So I'm going to round it to 0.01 and go ahead and do that. Again, building my formula, it would be starting at my fixed cost of negative 204.2, or my intercept. Plus, I'm going to go ahead and do employee first, 105.5 times 30 employees. Also, plus the fact that I'm going to take that negative 0.01 and multiply it times a predicted revenue of 2.5 million. Now, I'm going to do something, if you're struggling with this problem, I'm entering as 2,500 because recall on all the other numbers, we took off the last 3 zeros. So if you're struggling and you're checking my work and you can't get this, that may be your problem. And so my prediction here, based on these 2 items, is going to be total cost is going to be $2,935.80. That's really close to when we use simple regression. It was $2,930.1. But again, if we look at our R squared, we look at our T values and our P values, I don't think we're quite where we're at. In the real world, I'd want to keep looking outliers, or do I have different independent variables that I can use to better help predict?